I'm doing another SMO. This is from the junior section, year 2008. This is problem 28. I like these problems because I can actually do them without getting too much help. Now, it doesn't look like we're given a whole lot of information right here. We're given that alpha and beta are the zeros or the roots of this quadratic expression here. And we're also given that minus alpha is a root of this second quadratic expression equation. All right, and we are to find the product of these roots, alpha, beta. Now, something I'm going to do, and it always helps me, and I'm going to go ahead and share it with y'all. A lot of you might already be quite familiar with this, but for me, it's very useful to see the relationship between these coefficients and the zeros. And so since we are given that alpha and beta are zeros, that we know that we can factor this guy the following way. You know, for each zero, there's a linear factor, right? So you have x minus alpha, okay, times x minus beta. And this is just, I'm just writing down what's given. I'm not doing a whole lot of thinking right here. All right, so there we go. And that's equal to 0. Now, when you expand this out by the distributive property, you end up with x squared. And then what you will have, owing to the presence of these two minus signs, you'll have minus alpha plus beta And I'm doing all this because the Vieta's formulas, it always kind of confused me, how the sign alternates between the terms. It kind of bothered me a little bit. Why does that alternation really occur? Well, you can see it if you just go to the trouble to expand it out. Now, it gets tedious for higher degrees, but for this one, it's not so bad. Now, this plus sign here comes from the fact that you have a negative times a negative right here, right? So that's a plus coming from this minus, and this minus has nothing to do with alpha and beta. Now, and you have alpha beta. So you see at the end of this expression, you have the product of the zeros, which is what we're actually looking for. We're looking for the value of alpha beta. Now, so let's go ahead and use this information. And again, this is just reading directly from the problem statement, but alpha beta is equal to C. You see, if you locate the position here, C plays the same role as alpha beta over here. So C is equal to alpha beta just by inspection. Now, this was the part that used to bother me. Alpha plus beta is equal to 4, and it's really so easy that it's hard, I guess. But notice that what's going on right here, we equate minus 4 with minus alpha plus beta, and I'll write it down. You may think this is overkill, but it helped me to understand why you always flip the signs. We know by equating coefficients is what's going on right here, that we get this truth right here. Right, and this is just the well-known, you can equate coefficients, right? And what coefficients am I equating? I am equating the minus alpha plus beta, that is the coefficient of x over here, with the minus 4, that's the coefficient of x over here, right? And so clearly these minus signs cancel, and you get alpha plus beta is equal to 4. Isn't that cool? So that's why the signs change. And again, maybe I'm spending too much time on that, but it helps me rather than try to, there's something called Vietas that gets used quite a bit. And I used to just kind of memorize that without really knowing why it was true. And now I think I understand it a little bit better. Okay, there's a result called Vietas, but you really don't have to know how to even pronounce or spell Vietas if you just understand how to expand the expression. All right, and so this is all derivable information directly from the very first equation. Now, minus alpha is stated to be a root of x squared plus 4x minus c, and that's all I did right here was just substitute minus alpha here. The minus sign cancels, and you have alpha squared. If you substitute minus alpha right there, you have minus 4 alpha, right? So you have c equals alpha squared minus 4 alpha. And you see, we have two different representations for C. We have alpha beta equals C, and then alpha squared minus 4 alpha equals 0. And that's usually a good thing because usually you're going to be able to cancel some of the variables. Now, so this is the information from the first and second equations. Now let's move along. C is equal to alpha beta, but since beta is equal to 4 minus alpha, we can replace beta with 4 minus alpha from this statement right here, right? Beta is equal to 4 minus alpha, equivalent statement for this, all right? And now C is also equal to alpha squared minus 4 alpha. So you see we have C is equal to alpha, beta is equal to this, is equal to all this. Now this piece right here factors, right? This piece right here factors into alpha times alpha minus 4. And so I concluded right then that alpha had to equal to 0. And if alpha is equal to 0, alpha beta is certainly equal to 0, and you've completed the problem. Remember, it says find the value of alpha beta. So you're done with the problem. Now, I did leave out one step right here. If you string this together with this, you would get alpha times 4 minus alpha. Now, y'all, what do you notice here? These factors aren't quite the same. These two binomials, 4 minus alpha, alpha minus 4, they're what they call additive inverses, right? One is the negative of the other. And so what we can do is take advantage of that and rewrite this as minus alpha times 4 minus alpha. Right? Now that's a little more convenient. You can see it without having to do this, but I was just showing you in the event that was helpful. So for the 4 minus alpha factors would cancel unless, they would cancel out. And so this would imply that alpha equals to minus alpha, right? And there's certainly only one number where that's true, and that would be when alpha is equal to 0, right? Like if this were 3 and minus 3, they're certainly not equal to each other. So the only time this equality can hold is alpha is equal to minus alpha. And so we get alpha is equal to 0, and of course that forces forces alpha times beta to equal 0. Okay, I hope that helped. To me, this part about understanding the sign alternations in Vieta's formula is very, very useful. It's not always practical to multiply this out like if you have a third, fourth, or fifth degree equation, but for second degree, it's real easy to see why these minus signs would alternate.